So I'm trying to do the intro as formally as we normally do it. So on behalf of the School of Architecture, I would like to welcome you all to the public defense of Paul Poinet with his thesis, Enhancing Collaborative Practices in Architecture, Engineering and Construction through Multi-Scalar Modelling Methodologies. So to introduce myself, I am Mette Ramsgaard Thomsen. I'm Professor of Digital Technologies and Head of CITA at the Institute for Architecture and Technology here at the Royal Academy. And I have supervised this PhD as part of the InnoChain project, the Marie Curie action that we have been running for the last 4 years. So it's a great pleasure for me to be chairing this public defense, and we are doing so according to the ministerial order of the PhD course of study and the PhD degree. So we are actually, even if this is a bit informal, then we're following quite formal setup here. So first of all, I would like to welcome our expert assessment committee. I would like to welcome and thank Jane Burry, who's professor at the School of Design at Swinburne University of Technology in Melbourne. I would like to welcome Robert Otani, who's principal and chief technology officer at Thornton, Tomasetti in New York. And I, of course, also want to thank and welcome Daniel Lee, who's associate professor at the Institute for Architecture and Technology, also at the Academy. And Daniel will be acting as chairman for the committee and internal examiner. I also want to thank Fabian Scheuer, who's here, who has been one of the 2 industrial supervisors. Fabian is from Design to Fabrication in Zurich, and Al Fischer of Bureau Happold, who is not here, as far as I know anyway, who have both been really instrumental to supporting this thesis. And of course, also Paul Poinet, who I will give the floor to in a few minutes. I just want to tell you a little bit about the formalities of this. It's a little bit different because we're not in the same space, but it will still run in the same way that it would do if it was in physical space. Paul is given 45 minutes to present his thesis. Of course, this is many years of work, and 45 minutes is a short time, so we will see a particular view of the work. And after that, there will be a short break for 5 to 10 minutes. Where we will make it possible for the committee to discuss between them, but also for if anyone within the public, so all of you in Skype or in Zoom, have any questions, you can type them in to me in the type box, and they can be posed after the review of the 3 expert assessors. So this is a chance for you to partake in the discussion, but the rules of the examination in Denmark is that this must be previewed, so you cannot come with a great idea you had during the discussions, but you must have a discussion already prepared. And then, so then after that, we will run through the 3 question and answering sessions, which are half an hour each. And then the audience is given the possibility to pose questions. And finally, the committee will go into another Zoom room that has been prepared, and they will deliberate their decision, and they will then come back, and they can then recommend our rector, the head of school, the head of the Royal Academies, Schools of Architecture, Design and Conservation, to award the PhD. I hope this makes sense. So I think unless someone has questions, then we would go directly to Paul's presentation. Thank you so much.
Thank you very much, Mette, for the introduction, and I would also like to thank everyone for making it today, and yeah, especially Robert and Jane, who are in different time zones, and Jane woke up very early this morning. So here's the title of my presentation, which is Enhancing Collaborative Practices in AEC through Multi-Scalar Modelling Methodologies. So I just want to mention first quickly that you can access all the reading material as well as the presentation slides and videos on this link. And you will find this link also on each slide, so don't worry if I skip to the next slide now. So here are the content. I will go first through introduction and research questions, then the state of the art in applied parametric modeling in AEC. Then I will introduce the overall topic of multi-scalar modeling for building design, which is a theoretical framework as well as a research methodology. Then I will go through a first series of modeling-based experiments, which take free-form timber structures as a series of case studies. Here is the list of the different experiments. And then I will go through a schema-based and cross-practice collaboration experiments, which are listed here, and so the schema based on the left and the cross-practice collaboration on the right. And finally, I will conclude the thesis. So in pink here highlighted, you can see the experiments that I will more focus on. So first, introduction and research question. So yeah, Mette introduced already the overall research framework, so I will not go through it again. The aim and research objectives are: one, validating whether or not the multi-scalar modeling framework existing in academia can be transferred into the realm of the AEC industry, establishing new means of simulating and communicating complex data set throughout the whole design chain of the building process. Three, creating a theoretical framework acting as a larger software platform or infrastructure that could host the multiple custom prototypical software application developed through the thesis work. And the research questions are: how can a multi-scalar modeling framework allow the designer to work across different skills in order to take into account multiple constraints related to material fabrication and structural performance during both early design and late stages? And two, how can we keep track, add and modify data within a common directory structure until completion of the building? And three, how would an ideal multi-scalar parametric AEC model look like? Which requirements would it have to fulfill all users' requests? And how could the multi-scalar model be interacted? And what are the user interface and user experience concepts that would be required? So first I will go through the state of the art in applied parametric modeling in AEC. And I will start with this quote from Rick Smith, who was a consultant for more than 10 years at Burry & Partners, and unfortunately passed away last year. And he stated in 2007 that the concept of creating a fully parametric digital model of an entire project to accommodate variable changes is just not efficient at this time with the current state of technology. This is theory and operable, especially when trying to accomplish such an all-encompassing function on a 32-bit PC. So, and then he laid out these different points, stating that parametric models require a high degree of front-loading, that anticipating flexibility can be difficult, major changes break parametric models, changes can be hard to see visually, and reusing and sharing models is problematic. Of course, this echoes with the concept of separation, the concern which was first introduced by Esger Dijkstra in 1974. But the concept was actually taken by Alexander Peña de Leon, who stated that we need better ways to integrate automation in design modeling, while also we need more tacit interaction through direct modeling or manual interventions with our models in order to achieve greater flexibility in design modeling. And this separation of concern, actually, we have seen it emerging in AEC industry. So now I will go through different precedents from 1995. We Book de Vries, who identified different companies and identified the links between them and the data exchange between them, to Oliver Tesman, in 2007, in his thesis, he actually identified different design cycles in the design process, design to production. In 2010, they also highlighted the different CAD models that were needed and the different extension files that were talking through each other through the design process of the Centre Pompidou in Metz. More particularly, there are also this very interesting case study from Front Inc. and Blue Apple Engineering, who were involved in the conception and construction processes of the Morpheus Hotel, who was designed by Zaha Hadid Architects in 2015. So you can see on top is the building information generation from Front, who here they highlighted the data exchange between different sessions, between different Grasshopper sessions where data was generated, and sessions of Rhino files where data was stored and where metadata was attached to. And at the bottom is more the engineering perspective, who had to deal with structural analysis at different levels and pass information between different scales. There is also this example from Woods Bagots in 2017. This is the 11th project. It's a housing project situated on the High Line in New York. And here you can see they actually mapped also all the data exchange between different Grasshopper and Dino files throughout all the process, all the design process of every single building components. Of course, this development efforts does not only happen within architecture firms, but also from the perspective of the software industry. So here there is the example of McNeil, who quite recently introduced Rhino Inside and Rhino Compute technologies. So Rhino Inside enables to run Rhino and Grasshopper inside other applications which have .NET API such as Revit and AutoCAD, and Rhino Compute presents a REST API from which expert users can actually call Rhino functions on a server. And beyond the software industry, there are also consultancy practices or engineering firms that develop their own application to help other architecture firms, so such as Proving Ground with Conveyor, or the different applications developed by TT Core. And then we also see the emergence of data platforms for AEC. So of course, I'm sure quite a lot of you are familiar with Flux, which ceased to exist in March 2018 for financial reasons, but it was actually more used by more than 6,200 companies and 150 countries in the world, and a lot of like computational designers, engineers, and BIM professionals actually relied on this platform. The legacy of Flux, I think, is both Speckle and Constru. I think there are other data platforms for AEC out there, but those are the two main ones that I personally know, and you will see later in the presentation that Speckle was particularly relevant for a set of experiments in my thesis. And here is the state of the art in digital workflows. It's an overview, so you can see throughout the years, the last 30 years, all the examples that I just enumerated. And here's the period during I undertook the work in InnoChain between 2015 until 2019. So from the state of the art, we can actually start to extract a convergence. We can observe a convergence of concepts. So there is a general trend in developing neutral and open source custom tools and framework to break the silos. Also, we try to improve interoperability through custom software development, enabling the transfer of data-rich and complex geometrical objects. And also, the industry is ready to keep geometrical objects as lightweight as possible for serialization, further reconstruction, and using extensible neutral formats to facilitate both object customization and interoperability. And finally, the industry always tries to segregate the different levels of modeling from design to fabrication. So because of this very last particular point, this is why I also look at multi-scalar modeling, which is a cross-disciplinary concept that has been investigated within different fields. So it is recognized that the conceptual development of multi-scale modeling comes from the realization that the full behavior of a system cannot be represented within one single model, since the level of details differs from one scale to another. So we see that This has been used, for example, to model meteorological events, or looking more specifically at material, or in computational fluid dynamics or structural behavior simulation through adaptive mesh refinements. Multi-scale modeling has also been implemented. And also more recently in architectural design research, through coarsening and uncoarsening strategy that allows to communicate between different levels. We have seen also the implementation of multi-scale modeling. So, for example, at CITA, through the stress skins and the Bridge Too Far project, which actually implemented the adaptive mesh refinement methods, or with KADK, who looked at passing different simulation frameworks across different scales for the Landesgartenschau exhibition hall in 2014. So the different methods are trying to define coarsening and uncoarsening strategies to navigate across multiple levels and resolution, setting up connected pipelines, design workflows, and handshake techniques to deploy coarsening and uncoarsening strategies, and also deploying simulation frameworks and optimization strategies across the previously defined pipelines and design workflows. But however, I also think that it is fair to recognize that there is a discrepancy existing between academia and practice, because all the demonstrators and pavilions that are being built in academia present very material-specific and seamless designs, rather than in building industry. We actually face much more large diversity of material. There is more clashes between elements, and of course we have much more trades that are involved in the process. In terms of like data classification and data generation, I think they are also very intertwined. We can spend a lot of time upfront setting up all the workflows in academia, and so if you think of the dynamic data tree, but in Grasshopper, but then it's hardly sustainable at late stages. And on the other side, in industry, I think that the generation of data and classification are more independent for each other, so they are less intertwined, so that the user is more free to operate classification changes whenever he or she wants during the design process. So it's proved to be more sustainable at late design stages, if you think of the static layer table in Rhino. So we have these different points that come from the multi-scalar modeling frameworks that I enumerated previously, as well as the different points that I extracted from the state of the art from the AEC industry. And the question is, can we actually expand the multi-scalar modeling framework so that it actually incorporates these points from industry? So the overall methodology from the thesis work actually is placed under the scope of research through design, which and prototyping. So physical prototyping was defined by Thomsen and Mette in 2009, which is a materially led investigation allowing exploratory testing of craft and material behavior. But of course, all the work of my thesis those are only digital experiments. So I look more at digital prototyping or virtual prototyping, which is a shared method of digitally designing and investigating a product or process, which has been defined by Patrick and Lindsay in 2003. And then, so there are different categories of experiment. There are design probes. There is the prototypical application, which is a term that I define, which contrary to a software application, which is robust enough to be deployed through multiple machines and shared amongst different parties. A prototypical application remains at an experimental stage, so it's not enough to be it's not developed enough to be considered as a proper software application. Then the demonstrator actually deploys the prototypical application through stress tests. A stress test is also a terminology that comes from the software industry, which actually tries to verify the software through heavy load conditions. But as the present thesis work does not pretend to undertake robust and industrial software developments, stress testing refers more to the deployment and testing of a prototypical application against multiple models or case scenarios. So the experiments are therefore not evaluated against their usability, but they are tested against different models, scenarios, and collaborative practices. this is an overview, the map of the experiments. So you can see I actually highlighted the different methods. Some experiments actually learned from each other, accumulated on top of another. Some others are actually different series of experiments are compared between each other. Then different concepts from different series actually merge together and give birth to another series of experiments. So the modeling-based experiments actually look only at, particularly at early design stages strategies. I also connected and be part as a participant of a series of workshops. Then there are the experiment at late stages, which I named schema-based experiments and cross-practice collaboration experiments. So I fade out actually the one that will not present during the presentation and highlight here in pink the one that I will focus more particularly on. So first, I will go through the modeling-based experiments, which take free-form timber structure as a case studies. And as you understood, design to production was one of the industry partners. So it was great actually to be able to observe how they managed data from the global network to the modelization of particular design components. And as you can see, they actually sit at a very crucial points in the design process because they have to take into account many different aspects. For example, the structural requirements from the engineers to the geometry constraints and logistic from the fabricators. And so then I started to actually try to tackle through multi-scale modeling to define the different levels that appears through the conception of a free-form timber structure, from high level looking at the abstract network to intermediate level looking at a patch of different components, to low level looking at one particular component and material level. So here is the first experiment, which I look at blanks. So blanks is actually the raw glue laminated timber piece, which is milled down to the final shape of the segments. And you can see that for different geometry complexity, you have different types of blanks that are created, from straight blanks, single curved, double curved, and so forth. So here is a video that's actually by manipulating a waste percentage parameter, you will actually get different types of blanks. So the result is that this prototypical tool proved to be useful to generate blanks, steer the geometry at high resolution by manipulating very low-level parameters. But this experiment did not focus on the modeling of joints between elements, so the next experiment focuses this time on the higher level through the modeling of a large network of interconnected glue-laminated timber beam, which is topological mapping modeling lap joints. So here actually I started to set a framework where I could have communication happening between a graph at a high level and the generation of lap joint at low level. So where the user actually was able to select one particular joint and look at it more precisely within the 3D model. So it helped the user to visualize complexity, search, and query the model in a more intuitive way than through the direct modeling methods. But however, this computational pipeline solved a very particular design problem by only allowing two beams to intersect. So the next modeling experiments actually also demonstrate that the same graph modeling methodology that were employed in the previous one can be further deployed and stress tested against more intricate joint typologies and modeling frameworks. So this video highlights this idea where the user was able to actually very simply draw an abstract network at a high level, and you had direct segmentation happening at low level, glass panel generation. You are informed about the connectivity through the graph. This was happening only on one reference system, and then I was trying to add multiple reference systems, so different master surface, and also embed simulations, structural simulation, and at high level and also at low level by focusing on one particular node. And these are the types of outputs from these experiments. So it actually presented a frictionless user experience during the design process while navigating between the different scales. But it was actually quite challenging to craft every single design exception in such design process. And the multi-scalar modeling method developed so far actually have been tested and deployed through other research activities, such as the next experiments, which is the Tallinn Architecture Biennale installation competition, which was a common work done with Thomsen, who is also a PhD fellow at CITA and was part of the InnoChain, is part of the InnoChain research framework. You can see that during the conception phase of this project, we actually employed similar multi-scale methodologies, looking at abstract networks through base mesh generation, and then more finer mesh refinements and detailing. So then we actually we could actually set bidirectional workflows between the 3D model and the corresponding graph, which actually highlights all the complexities of every node's node's valence that were present in this timber structure. So this is the final outcome. So this is a render. It wasn't built. We got to the second place. But even if it wasn't built, we also looked at fabrication strategies. How can we actually extract one particular components and generate all the data necessary for its fabrication. So here, a blue laminated timber piece. And of course, there was also the question of feedback. So here I illustrated how we go from the mesh-based graph to the beam model, to the material model, and so on. But we also question how we could actually, how the lower level could actually feedback the higher level. So learning from this experiment, I think that we realized that seamless design strategies and integrated feedback loops only exist partially and not globally. Communication can be also quite difficult, and a certain amount of residual models were created for this demonstrator scale research project. And by residual model, I mean all the models that you need to communicate if you were wrong about certain units, and I mean all the models that are not necessary for the design of the project. So coming back to the discrepancy between academia and practice, I think in academia we have the luxury of to have a total control over design intents, but in industry it's more fallacy. Design happens throughout the project with the participation of all trades until completion of the building. Like this quote from Donald Knuth in 1972, who stated that premature optimization is the root of all evil. So as soon as you start implementing design and making decision on top of your like former abstract design space where you had a lot of flexibility, then the design space becomes very heavy and inflexible. So I'm sure you, most of you know the cost of the design changes curve, which increases during the timeline of a project. And then the proposed solution is saying that the design effort should be placed at early design stage. And then there is the consequence methods, early stage design activities to tackle this and to flatten the curve. Of course, late stages can be prevented, but I think they will ultimately have to be challenged. So I think that we also need to focus on the late stages concerns. So this leads me to here to the schema-based and cross-practice collaboration experiments, which tackle more particular late stages strategies. So very quickly, this is a state of the art in organizing data in industry. So you see that in the end of the day, everything is a tree, from the Rhino 3D layer table to the AFC tree structure to the tree directory in digital projects. Some of these trees are used to classify the data. Some are actually used to link parametrically elements, geometrical elements, such as in digital projects. So looking at this, I was also very interested to look at how design to production actually classify the data throughout all the design projects. And I was interested in investigating alternative means of representing this complexity, which led me to moving from the directed acyclic graph and to the more simple sunburst diagram. So this sunburst diagram here actually highlights the hierarchy between the different layers, and each offset actually represents the number of objects contained within one layer. So this could actually be stress tested against different models from design to production, and it was actually interesting to have a direct overview over the complexity of a project. And actually this complexity is not inherent to the scale of the project, because as you can see, the one on the right is only 7 to 8 meter high, the one on the left until 19 meter, but the complexity of the smallest one is much more intricate, and that's because it was actually post-rationalized, and rather than the two others, to take Robert H.'s term, embedded rationality, or were pre-rationalized. So this experiment called layer footprint could leverage data and highlight the model's intricacy. But however, the amount of information displayed by layer footprint may be too intricate and complex to be grasped as a whole. So therefore, the next experiment actually tried to extend the capability of this experiment by integrating more features, such as Layer Explorer here takes a similar sunburst diagram, but actually enables the user to navigate through it and focus on different branches of the layer structure. So you can see that each slide corresponds to a certain level in the layer table, and you can do that until you reach very specific components from the building. So here the user is finally able to focus on local levels, navigate between them. But this experiment, although it was presented along the 3D view, it actually operated outside the 3D modeling environments. So the next experiment is actually trying to embed such interface directly within the 3D model, such as layer stalker here. So this also embeds other features here. What the user is able is to type a certain tag or words, which will highlight all the layers whose name actually contain this specific tag. Then you can display the corresponding information in the viewport, refreshing the viewport, and so on. So you could actually perform unstructured queries and structured queries as well if you wanted only to focus on a particular leaf. So this present experiment demonstrated the possibility of performing both structured and unstructured queries from the 3D environment within the graphical user interface of Layer Stalker. But it was possible to deploy and stress it against multiple 3D model. However, this worked exclusively with Rhino, so with one particular software. So then for the next experiment, I wanted to investigate alternative strategies to share data sets on a more object level and across models and software platforms. So this is why here I looked at one particular object where you can see actually has many different sub-objects and a very intricate hierarchy of object contained within it. And here I was actually able to transfer this object via speckle and retrieve the hierarchy in another, I mean, still in Rhino, but in another Rhino session. So here you can see that through the interface, the user is able to select one particular item and add it in the tree, select some properties that the user wants to keep, and add it to whatever leaves that is in his personal tree. You can see that each time that you add an object, a sub-object to an object, then the parent-child relationship is highlighted in the 3D model on the left. So soon you will see that the object will explode. And finally, you can then receive this hierarchy. So that was sent via speckle. Then you can receive this hierarchy in another Rhino Grasshopper session where you can unnest all the data that is contained within this object. You could also retrieve one particular piece of item. So this present experiment demonstrated the possibility of building a data-rich hierarchy of objects and transfer it via speckle to another Rhino grasshopper session. But the next experiment, the data exchange operates from and to the same software platform, and the schema remains the same. What the next experiment looks like, it will investigate how to transfer a similar object across a different host application and adapt its schema accordingly. So here's the first cross-practice collaboration experiments between actually Burry and design production. So you have to imagine that here all the hierarchies that I showed you so far are from design to production. So they are really focused on the geometrical description of the objects and have their own tree structure. But of course, Burry engineering is not interested particularly at geometry, but more at how to, at the structural description of the same objects. So then the company has, of course, another worldview on these objects. Then the question is actually identify and find the commons, the shared description of this object, which could be just, you know, 2 endpoints or 1 polyline or a set of different planes that could be set as a shared description from which the 2 different companies can communicate. So yeah, so this is highlighted here. Where so the schema, so this actually combines, is a transfer that combines both, a transfer via speckle and BOM, which is a building habitat object model, which is also an interoperability framework developed by Burry. So yeah, through this experiment, you could see that you could transfer one object from Rhino to the robot software package for Autodesk. So this cross-practice collaboration experiment hybridizes modeling-based and schema-based strategies to transfer data-rich geometrical information across trade and scale. But although successful, it was only it focused particularly on the local adaptive object schema. But I think we still miss the bigger picture of the project scale. So this is what the next experiment is focusing on. So this is the CIMO. This is a workshop that was led by Dimitri Stefanescu and myself at TU Delft in 2018, where we actually shared different grasshopper session to the different participants of the workshop. So here you can see that you think it's unique grasshopper definitions, but they are actually shared to different participants and connected via speckle senders and receivers. And the idea was trying to automatically generate a graph that was highlighting the design exchange between the different grasshopper sessions. So this shared workflow setup across the participants enable them to communicate in a seamlessly manner across their respective design space. So although segregation proves to be useful to separate the concerns, I think it does not mean that communication should be disabled. Instead, communication channels should be maintained with the possibility to enable them whenever the design users wish to stream the data during the design process. But this experiment only tackled a design scale during the workshop. Of course, the question remains open on how the system would have behaved throughout the real-world building design dataset. So here I placed back the Morpheus Hotel project ecosystem, which I think could benefit from these experiments. So I reach now the conclusion and future direction. So here again, the research question. So how can a multi-scalar modeling framework allow the designer to work across different scales in order to take into account multiple constraints related to material, fabrication, and structural performances during both early design and late stages? So what I think is that the further hybridization of the modeling-based strategies and custom software application constitutes actually the final multi-scalar modeling framework for building design, allowing for both integrative automated tasks at early stages and more direct data manipulation at later stages. So if we look back at the different experiments, first you have the early design stages strategies, but at some point I think that the complexity becomes too high. So I think that we need to look at more like an object level, how we can actually build, assemble, and sharing schemas for specific objects. Then from this we can move to a more like model level where we can actually leverage, visualize, query, navigate through more like larger data sets on a model level. So by model I mean just like, you know, a full Rhino model. And then we can move forward to the project level, tracking data flow and linking multiple scales together. How can we keep track, add and modify data within a common directory structure until completion of the building? So developed through the present thesis work, layer footprints allowed to visualize complex architectural data sets. Layer Explorer and Layer Stalker enable the user to visualize, navigate through complex schemas in a more sustainable way, and Schema Builder enabled to build data-rich custom geometrical dataset that could be directly shared and queried through the open source Speckle platform from and to multiple Rhino 3D documents. So although the mentioned common directory structure here has not been developed independently through the present thesis work, the theoretical multi-scalar modeling framework has been partly demonstrated through the use of an open source communication platform Speckle. So it is suggested that underlying object infrastructure of the multi-scalar modeling framework should remain open source. And then 3, how would an ideal multi-scalar parametric AEC model look like, and which requirements would it have to fulfill all user requests? How could the multi-scalar model be interacted, and which user interface and user experience concept would be needed? I think that the integration of the developed prototypical application within a common directory structure or open source communication platform would partly shape the ideal multi-scalar modeling framework for AEC. Realistically speaking, I really think that, you know, user requests might change and evolve over time, and it is difficult to give a clear picture of the final developed interface that would be gradually improved before becoming more and more crystallized. I'm making a digression here because this work is not part of the thesis work, but as more like future direction and perspective. I think that, you know, some of these implications can be integrated further within software. So the last experiments that I presented at the end of the presentation actually was you know, implemented further, and actually now is a proper web application that is part of the Speckle framework. So yeah, that's it, and thank you very much for listening.
So if we start now, then we will do the 3 rounds of questions, and the order is that Jane will start, and then Robert Otani will follow, and finally Daniel Lee. Yeah, so thank you very much. And Jane, do you want to start?
Thank you, Mette. So thank you, Paul. That was a really accomplished presentation. I think I've actually found it invaluable to have your 45-minute version of your thesis and the argument and evidence that you're presenting to support it. And I feel I understand the thesis and its construction much better actually after that presentation. So following our opportunity to read and collectively report on the thesis and now to view your presentation, it's obviously my privilege to pose you a few questions. I'm going to respect the fact that Robert's coming immediately after me with a very current industry view of this, and also that Daniel will bring his expertise in the engineering architecture interface. So I'll just say to you, I'm sort of questioning you as an architect and an academic with a lot of involvement in PhDs, and I'll attempt to just put some very high level framing questions in place that will provide a sort of scaffolding for the discussion that comes after that. So first of all, just taking the first part of your title, Enhancing Collaborative Practices in AEC. For us, I think as the panel, the kernel and the most interesting and significant and original part of the thesis for us was in chapter 5 with the layer footprint, layer explorer, layer stalker, schema builder, which in reading about them and then in seeing them presented, very compelling tools. and they really appear to address a lot of the information and communication challenges that many practice industry academia would identify very closely with. Especially, I suppose, in managing information for complex and bespoke projects. So the way you've written about them in the thesis, you've really given us a very structured progression of prototyping experiments, one building on the next. And to some extent, they seem to have all of accumulative, comparative, serial, expansive, and probing, to use Crow's terms in yours. They progress very systematically from analytic, descriptive to synthetic. And I know, you have the chance in writing the thesis to restructure that. But my first question is, do you agree with that? And would you like to talk a little bit more about your approach to iteration and the experimentation in building your experimental evidence, particularly in regard to the schema-based and search interfaces for later design?
Yes, so I think some were accumulated on top of another, learning from the precedents to move forwards. So in particular, layer footprint, layer explorer, and layer stalker. I think they are they look at they focus on the same scale and analyze similar 3D models. Then for the next, for the other experiments such as schema builder or the collaboration practice between bureaupports and design to production, or the workshop that we did with Dimitri in 2018 at CMOD, I think those then actually try to look at other scales. So the schema builder looked at a very particular objects with a lot of nesting information, and and then in the workshop we more like looked at higher level like projects, data exchange within the projects. So yes, I agree that the experiments learns on top of each other for just the layer stalker, layer footprint, and layer explorer.
And for you, are these tools themselves a significant part of your contribution, or is the theoretical framework more key to the whole contribution?
I think I mean, I would say both, because I think that like for example, all the modeling experiments in the first part, actually it was kind of a process that I had to go through to actually start to realize, okay, I cannot only look at the thesis from this particular perspective, but I need to to zoom out a bit and look more at the like projects data, for example, from design to production, which led me to the second part. So I think, but I mean, I still think the overall framework of multi-scale modeling, stating that both parts should actually ultimately communicate with each other. I mean, technically, I am aware that there is more contribution in the schema-based cross-practice collaboration parts. On a technical level, I think there is more contribution, but on a conceptual level, I think everything needs to be, of course, taken into account.
Right. Yeah. So, I mean, I wasn't to devalue chapter 4 and all the modeling experiments, but I guess we didn't see as much that was looked to us kind of fundamentally significant or original in the modeling experiments. And, they were certainly, you can see how the whole thing builds and accumulates, but somehow the very significant kind of contribution seemed to be in chapter 5. Mm-hmm. Something that occurred to me while you were presenting was that you had a very particular situation. I know you weren't actually embedded for very long, but with design to production, you had a very, I can be very confident that you had a very highly, rigorously structured models that you were looking at there in terms of the layers that you were pulling apart in layer stalker and so on. So, I mean, that's interesting. Do you have any comments on that in terms of you know, it's great to start from a high base like that, but
yeah, I
know,
mean,
in terms of generalizability in practice.
Yes, I mean, I can only thank a lot Fabian for making, you know, such such amazing models, which were really, you know, resourceful for the thesis. But of course, not everyone keeps its model clean, like you know, this clean. So of course, then subsequently, the, you know, the layer stalker and all these experiments, you know, they are useful, but there is always a part of responsibility from the user, so that these different prototypical application could be deployed and benefit the expert user. But, you know, I mean, sorry, just to expand on that, I also think that, for example, it's also led me thinking about the schema builder experiments, because for the schema, I thought, of course, not everyone structure its subject like this. So I also wanted to make an experiment where people could actually manually, you know, just on the fly grab objects and building relationship within them in a more in a more bottom-up approach. So yeah.
That could be interesting. I think that'd be an interesting line to follow, because you know, in terms of disciplining people, it's very hard to get people to even use consistent subject lines in email. But right, yeah, we'll come back to that. So if I take the second half of the title of your thesis, through multi-scalar modelling methodologies, so you're going to support collaboration through multi-scalar modelling methodologies. And you've done some very detailed referencing of multi-scalar modelling from others. And, you know, that was, again, very good to see in the presentation. And you picked up some very useful concepts in the early chapters, like separation of concerns and distress and discrete event simulation. Also some statements about multi-scalar modelling that some people might have counter arguments to. For instance, that multi-scalar modelling originates in academia. And it really, you know, it's a bit of a semantic point whether you put the capital letters on it or not, but many would see it as underpinning our entire mode of creation and production in AEC, probably going back to Roman and medieval examples, but you know, and even more pronounced maybe in the history of mechanical engineering in Silicon Valley. But certainly very powerful concept in the digital modelling in AEC going back to like the 60s, admittedly academics like Ivan Sutherland and Coombs. But you've said that it preceded parametric, generative and computational modelling, whereas again, some might argue that these are actually potential components or sub-methods of multi-scalar modelling. So since in a PhD, actually definitions are very important in framing the thesis and the argument, I would like to offer you the opportunity to articulate for us your personal definition of multi-scalar modelling. And there's a second part to that question, but maybe I'll let you start with that definition, if you're comfortable.
Sure. So as you know, the terminology suggests, it's multi-scalar modeling is modeling process at different scales, and I mean, of course, they are because of the AEC industry. Of course, I think that the generative and computational concepts need to be included, but I agree that I mean, those are not the only concepts of multi-scalar modeling. So some others, for example, there are, you know, as I also mentioned in the presentation, the uncoarsening and coarsening strategies that allows to move from one scale to another, or through what people have called handshake techniques, so which is sort of like triggering an event and said, okay, I've finished, you know, operating at this scale. Now give me all the all the information that I need to move towards to the next. This, you know, handshakes technique concept coupled with, you know, generative modeling happening in, you know, different decentralized local pipelines. This constitutes the definition, I think, of multi-scale modeling for AEC, at least in early design stages. But of course, I mean, that's you know, the whole point of my thesis, that also it also needs to be expanded to incorporate more like late stage design strategies.
Mm-hmm. So it's, I mean, you're treating it very much as it's a digital concept, multi-scalar modeling. It is about those interfaces between scales. This is the critical.
Yeah, it is about, I mean, it is mainly about the interface between the scales, yes.
And the second part of the question is, just returning to the contribution, have you personally contributed to the field of multi-scalar modeling specifically? And how does that, the multi-scalar modeling aspect of that, frame your significant original contribution in the thesis? How important is multi-scalar modeling concept?
I think, I mean, what I think is that multi-scale modeling is interpreted differently across different fields. So, of course, in mathematics, we will use, you know, certain concepts, or in you know, for looking at structural behavior of specific material, there are also concepts of multi-scale modeling deployed there. So, if you ask me if I contributed to the concept of multi-scale modeling in the field of mathematics, of course not on you know, on a technical level, but I think multi-scale modeling is a very high level concept, and I really think that I contributed to this topic, but from the scope of the AEC point of view.
Mm-hmm. And what would be the sort of, are there any sort of really critical things from your point of view that are the most important kind of novel and significant aspects of that?
Then yes, we move back to the former question, where, I mean, I think that technically what I contributed the most are the experiments deployed within the, you know, schema-based experiments. I think those experiments contribute to the topic of multi-scalar modeling within the scope of AEC.
Mm. And I guess the synthetic aspects of that, or analytical and synthetic equally. It seemed very, I think what was quite exciting was the way that you moved from being able to map an existing model to being able to then sort of intercede through a very similar tool in that space. So, okay, PhD is a very compressed and focused slice of time in research. You have to be very focused in that space. And you've obviously just achieved an enormous amount during yours, and you've worked in a really complex context involving multiple academic institutions, industry partners, Bureau Happold, scientific production. And, you know, some of that industry experience seems to have been very formative. You tested your propositions and prototype solutions mainly through academic workshops. You can correct me, I know some of those were also cross-practice. And so as you've acknowledged yourself in the presentation, it keeps it a little bit in the speculative domain. So if you had more time and opportunity, beyond kind of strength testing in workshops, would you have wanted to validate and user test your tools and modelling approaches in other more rigorous ways? And if so, how do you think you could have orchestrated this within the scope of the PhD?
Yes, so I mean, if I would have more time, I think I would have developed in a more robust way each application, and make them not prototypical application, but actually proper software applications. In terms of stress test, of course, I was looking mainly at the models of design to production, and also from Bureau Rapport in the last experiments. I mean, they were my industry partners, so they were willing to share models to me, but I'm sure you know how hard it is to get models from others industry firms out there due to PI policies. So of course, if I would have more time, I would have also tried to gather much more resources and test my experiments against other externals models as well. And coming back also to the part of my conclusion, which is about the perspective part of the conclusion, where I highlighted the fact that I actually continued working on one experiment within my current job, and here I actually moved it further. So this prototypical application is actually now part of the software. It's a proper web application part of the Speaker framework. So yeah, if I would have if I would have had more time, I would have of course done that for each one of them, basically.
So with the cross-practice collaboration experiment, you're basically, rather than splitting your data, which is something you might do as a validation experiment with two lots of data, you're using the same data but through two different protocols to see how that they communicate.
Yes,
so do you see that as a sort of mini validation experiment?
Yes, but I mean, it was a validation because the both schemas could be actually transferred and communicate set on a specific. They could communicate between themselves through a specific setup set by myself. So of course this is a very niche experiment, but I think it just by actually transferring these schemas and being able to adapt from one to another was a validation in itself.
And you were also talking at the end there about the AEC Delta Mobility Project, which you popped in as a kind of postscript in your concluding section in the thesis. But I guess it's sort of spanned the time of the PhD and then into the post-PhD. Do you want to talk more about that and how that's constituted something more like user testing? Or, I mean, you speak a lot in the thesis about what the users might do, but how can you substantiate that at the moment? Does the Delta Mobility Project provide that platform?
I'm not sure if it's okay to maybe share a video now, Mette, or no?
Mette?
Or I'm okay to illustrate this project and show you what it does now, but I mean it would be better if I actually show that through video. I mean it would be more relevant than if I just tell words.
I think go for it. I think go for it.
Okay, so
the formalities. Yeah.
Sorry. 1 second. Okay, so the last experiments that I was presenting in the presentation, the workshop experiments where we were mapping the different users and the different data exchanged. So this was actually the concept was brought further, and this is now a web application that is part of the Speckle. So this is the part that shows you all the documentation. So there is different features that enable the users to see where the data is actually going going from and going to. So like you have a different set of icons that this is to say that the data is sent, this is to say that the data is received. This icon is a grasshopper, so it's a grasshopper document that has different senders and receivers from Speckle. You can also map users, so this is me based at UCL, where I had a bunch of different receivers and different senders. And so yeah, of course, so here there are more user implementation where the user is actually able to select different nodes and navigate within the graph. Here you can also shift the view between the data flow per users in blue or the data flow per documents in pink. You can as well always click on a specific stream. So a stream in Speckle is a collection of objects, and view it in a viewer, or you also have this filtering feature by time, where you can see the data actions that happen in specific time in a research project. So so this is what I developed further after the PhD work through the AEC Delta Mobility project.
And so who's participating in that project at this point?
Sorry, who is participating in this project? I didn't.
Yes.
Okay. So you.
Okay. Is this also a tool building exercise, or is this being tested or used in some kind of beta way by people?
This is so the tool is out there. So anyone who has a project, handles a project in Speckle, and can actually see this, visualize their own data flow. But then again, the data questions comes again, because during the grants, when we tried to reach out people to illustrate how they would communicate data, there is also this IP issue with a NDA clause. So we always have a hard time to get data from people in practice that would make use of this tool. So, but we had a lot of.
Do you have any other form? Sorry.
Yeah,
do you have any other form of feedback from people?
Yes, actually, we were in touch a lot with Grimshaw architects who are very interested. So in London, who are very interested in this particular tool. So now, I mean, actually, currently, I'm actually writing a paper with them, which will be published for the Design Computation conference in London. And they were mostly particularly interested in the user selecting different streams directly within the graph based on different user tags. So for example, like if you remember the layer stalker experiments, where I was able to type one specific tag, and then it highlights all the layers that contain this tag. So the same principle is actually implemented within the graph, this tool as well. So you could actually query all the streams that contain a specific tag, highlight them, and have them in the viewer. But and of course there are other features that they would like to get with the graph. So now the idea is to transform this graph more into a project management interface.
Mm-hmm. And actually, I think I'll move on to another question, because I've got about 5 minutes left on by my calculation. In the thesis, sorry, this is a bit of not a very natural segue, but in the thesis, you strayed briefly into interdisciplinary design, communication, and collaboration, and that's Of course, that's quite dangerous territory because there's such a vast volume of work in those areas in relation to computer-mediated work, coming from every point of view over at least about 6 decades. But so I would question whether you needed to go there explicitly, mainly because it's just like another entire PhD. But nevertheless, you did briefly go there. So how much did that interfacing and orchestrating communication between disparate disciplines and disciplinary languages in AEC shape your approach to multi-scalar modeling?
I'm sorry, but could you please repeat the last sentence?
I'll ask the question. Yeah, I will. I definitely will. How much did interfacing and orchestrating communication between different disciplines and disciplinary languages in AEC shape your approach to the multi-scalar modeling?
I think sorry, just to be clear, you refer to here. You refer to the state of the art that I wrote in the written document, right?
You now that would I've got it right next to me, but it might take me a little while to go back and find. You had a little section at the end of one of the chapters. I'll have to remember which one it was, whether it was 2 or 3 or possibly even 4, where you referred to you went into a sort of reverie where I think it was 3, where you acknowledged that there are a lot of human factors, and that design, communication and collaboration was a major issue. But you didn't go into it in any particular depth. You had 2 or 3 pages there where you dealt with communication and collaboration. You've forgotten too. Okay.
I'm sorry.
I can probably find it. Anyway, I don't know if it would help if I told you where it was. But could you answer that one off the cuff? So do you know what I'm talking about here?
I thought you were.
For instance, you're dealing with looking at communication design and visual interfacing. But as we know from much work that's gone before, whether we're architects, engineers, where we're coming from in terms of our background, what type of engineer, we deal with information in very different ways. So in terms of both kind of computer interfaces, but also the formatting of information, how much did that, consideration of different disciplines, for instance, how much did that influence your approach to the multi-scalar modeling?
Sorry. Now I'm looking at the written document of my thesis, and I think you might, for example, refer to 2.1.4, which is existing UI and UX concept for visualizing, filtering, querying, and exploring.
No. I wasn't talking about your precedents. I was talking about a section where you acknowledged communication as a major issue and dealt with it briefly. But it doesn't matter. It's really not important. But would you like to answer the question, or is that one?
But I don't know. I don't know if I will answer. No, I'm sorry. I just don't understand the question.
You don't understand the question. Okay, I'll try once more. You talked about design, communication, and collaboration. You know?
Yeah, but in the state of the art, I acknowledge that there is a lot of design collaboration, friction between design collaboration. So for me, so I think about the state of the art.
Let's just agree that you acknowledge that as a problem, and including human factors there.
Yep.
Yes. A lot of that can be, all sorts of differences between groups of people. One of those is discipline and disciplinary background, and the way information is received in different quarters. Mm-hmm. So in terms of designing the tools, how much did that play into your to your thinking about designing those tools and how communication works between different disciplines and different different hegemonies.
Yeah, so I apologize for being so slow, but I think now I visualize now what you're referring to in the written document. So I think it's, you know, what there is this diagram where you have two heads and you know, different groups of people, and first you know, there is the whole like meta level of the company's philosophy, and then when you zoom in, you have the personality of the individual that actually communicate this data to another person that's situated in another company. So so for me, it's that these two different individuals have, you know, different trees of knowledge, and of course, ideally what we would like to do is just take one branch of my tree of knowledge, giving it to you, and assuming that you would take this branch and merge it in your tree of knowledge. So for me, I took this particular you know, this particular concept and actually looked at it and tried to implement it in the cross-practice collaboration between design to production and bureau reports, because, you know, they work with different schemas, they work with different there are two different companies, different individuals, so they have to communicate, although they are working on the same projects. They have different they have differences, like both, you know, both technically, also philosophically.
Thank you very much, Paul.
Yeah, you're welcome.
I'm happy, Mette.
Thank you very much. Yeah. Very good. So we'll just, without much ado, hop over to Rob. Thank you very much.
Hey, Paul. How's it going?
Hi, hello. Fine. How are you?
Good. So first of all, I'd like to, you know, congratulate you for doing such a thorough research project on a very difficult problem.
Thank you.
So I found this PhD, the thesis, very sort of informative, but also opened up a lot of ideas as well. So yeah, I mean, you did a ton of research, tested various case studies, you know, attempted to apply the approach to various projects. And so, I will say that, and I'll get to it a little bit later, that, you know, they were very specific types of projects. So I think, you know, one aspect of design and construction and fabrication is that not every project is different and will present a new series of problems along the way. But generically, you know, it's pretty clear that data interoperability is key to, you know, having an approach like this. And so, you know, obviously you've done a ton of work with Speckle and have done research on other interoperability platforms, you know, including Constru, which, you know, thanks for putting that in there too. But so what do you see as, you know, because, you know, let's face it, nobody has completely solved this issue of interoperability and data transfer, particularly bidirectional. So what do you see as sort of the next steps for that topic in itself, because it is part and parcel to your multi-scalar design approach?
Yes, thank you for the question. I think that I think the main problem is that a lot of different you know, software, custom software applications are developed in isolations from many different practice, also the you know, the most expert ones. So, you know, people always need to redevelop, not necessarily even develop for themselves these particular tools. So I mean, ideally, but, you know, it goes you know, against business. But ideally, ultimately, I think it would be great if the underlying infrastructure will be open source. So of course, here I refer to Speckle, because if if I develop one of these prototypical application that I presented in my thesis on top of it, then well, everyone could see the code and potentially using it with Speckle. But so you could, and of course, if this framework is open source, it's open enough so people can actually build on top of it. And Constru is another data platform, but it's not open source, so it's not open enough to me to say, okay, I'm gonna just grab this specific feature and just expand it to fit my needs, because yeah, it's just simply not open. So for me, I think the next step is just to go full open source. But I mean, I know I'm very biased because I developed most of the experiments with Speckle, but if it's Speckle or another open source platform, for me, just that it should be open source, so we can actually build applications on top of each other and benefit the most from that. Yeah.
I mean, I will say, and I don't want to get into an open source discussion, but one of the challenges of open source is creating a platform that is, I'll say, has enough governance to where it is usable across many, at least the majority of people, as opposed to being very specific. In other words, not everybody has the ability to, program like yourself. So there would need to be a simplified version so that everyone can use. And I think there's some problems with other open source software that has been developed to the point of being too complicated for a lot of people to use. So anyway, just moving on to the next example in a more specific topic. You had a chapter about discrete event simulation, which I thought was interesting, actually. It had a lot. There was some interesting sort of triggers, I would say, right? It's an approach where a certain design decision triggers another potential decision or becomes an input for another analysis. So, I guess my question is, do you think discrete event simulation can be codified in some way for a particular design project?
Yes, I mean, I think so. I mean, I think that in the end of the day, discrete event simulation, as the name mentioned, it's events. So I think if you define what is the exact event that will trigger your modeling pipeline to talk to the next, then you just set you set the events, and then of course I think you can codify it by simple rules. So yes, I mean, short answer, yes.
The reason why I'm interested in that, and I think it was a good, although it was relatively a short part of the thesis, is that I can see just from my own experience that there could be it could be a very important, I would say, workflow in a design project as it relates to construction. In other words, if the event was a certain, not necessarily construction event, but a data event, right? That would then trigger some other, let's call it, let's as an example, we'll use it, for construction bidding, right? If a certain specific data point was created, and then the downstream contractors, fabricators would have that data to work with, and as the project gets designed, the various subcontractors would have a complete list, a complete data set that they can work with.
Mm-hmm.
And so I'm just wondering if you've thought about that, not just in terms of how data is connected and how scales are connected, but how data is connected to the various stakeholders.
Yeah, I mean, actually, maybe not through the thesis work per se, but actually this makes me think of also discussion that I had with the people that are working at Grimshaw Architects, is that when they saw the graph, they were also mentioning that, okay, can we actually have different status for each stream that say, for each node in the graph that say, okay, this model is valid or invalid, or this is completed, this is good information, or and so forth. So I think that on a higher level, of course, you could give the user the opportunity of set these different status at different points in the building process. And then that would actually tell the subcontractors whether or not the data can be taken by them or not.
Right. I mean, you can also think of that also as a design parameter,
Mm-hmm.
because obviously there are sometimes literally hundreds of people working on a design project. A lot of the data that's created many times gets thrown out along the way, and so, but there are some data points that need to be kept. And if there was a way to classify certain data points that are gospel and that need to be kept, then you can create that same sort of bucket of an event, right? And sort of the known, don't touch this data point, or I should say that this data can be used for further triggers for the design analyses.
Yep.
Anyway, yeah, I thought that was interesting topic for me. I want to move on to you had a very detailed case about the topological mapping of complex timber structures. Very detailed, and I was wondering, just in general, what were some of the key takeaways, key lessons that you learned from that study?
Yes. So I think I observed that it's actually possible to go very detailed and very deep in such setting up such a pipeline, but and then once it's properly set, then I really think you have a frictionless user experience, and you can actually achieve quite a bit with it. But the problem, I mean, the key lesson basically is actually not so positive one, because this is where I kind of realize myself of the difficulty of changing these pipelines to integrate further design exceptions in generative modeling. You can really have to break the grasshopper definition and redo a lot of stuff, and that's back propagates at the beginning of the parametric definition. So actually one of the key lessons is that it's actually hard to change the pipelines once you actually set it up properly. And yeah.
No, and I think that's a good lesson, because I think that's a lot what we've learned is that although the parametric design is very powerful for design studies, parametric design at some point gets broken. And you had a good description of these residual models that you needed to create just to communicate potentially with various stakeholders. And so the only one comment that I would have is about parametric design, in my opinion, is not necessarily a necessity in the multi-scalar design approach. I think it's important for the early stage of the design, but not necessarily a necessity for the connected data approach. The other, I would say, lesson that I think it seemed like you took away from there was or at least in some of these other design examples, and I think Jane was getting to it a little bit, was the human approach. Humans are not parametric necessarily, nor always logical. So is there a way to implement, let's say, the non-parametric, non-illogical decision point within, sort of your data tree?
Yes, I mean, I think this, for me, short answer, I would just refer here to the schema builder experiments, because I think that's the tool that allowed the user to be the most illogical and informal as you can possibly imagine. Because, I mean, of course, in the experiments, you see that it's a perfectly organized object that was generated by design to production, so you could see all the hierarchy that existed before. But my idea with this experiment is that you could be able to manually create hierarchies on the fly and send that to someone, and this hierarchy that someone creates it could be logical but also illogical. I mean, for me, in this particular example, everything is about the human able to communicate necessary structures of data to someone else. Yep.
Do you see there being, let's say, a keeper of this model? In other words, again, you're an experienced, computational designer and modeler, but many people aren't. So, in a way, the framework needs to be bespoke enough so that there can be some manual implementation. Do you get my question? In other words, in all these studies, you are the keeper, right? But in a real project, there needs to be. That's why I'm asking the question. Does there need to be someone who is making sure that this connected data approach is governed?
Yes, I think of course I mean, someone has to be in control of the data. So yes, I think someone should be in control and oversee all the data operations. And coming back also to the high-level graph that's from Speckle Viz that show all these different communication between different stakeholders. At Grimshaw, they were actually seeing this as a tool that could be used by managers, design technology or BIM managers, to be able to oversee the data workflows and the different pieces of the model for specific projects across the firm. So they were actually seeing this as a tool for the gatekeeper. Yeah.
And do you see that, for instance, in terms of the scale of the project, that each element, each manifestation of the design, which are usually a BIM element, let's say, has a specific human ownership?
Yes. Yeah, I believe this should be the case. I mean,
so each individual would have a node, basically, of inputs and outputs.
For each single element, I mean, I understood that you meant that for each object in the model is owned by a human.
Yeah.
Yes.
Exactly. So I guess
sure.
my question, because if you, for instance, I'm thinking about structures. I'm a structural guy, but if you look at any building, even a single floor plan potentially could have 5 different owners, right?
Yep.
With hopefully not 5 different sources. It's it's possible. And so, do you see your graph essentially having that level of detail?
Yes. I mean, if you speak about the Speckle-Vis, the metagraph, yes. I mean, when I was mentioning that you could query through this graph the streams by tag, you could also query them by ownership. So you could say, please highlight all the design objects that have been shared by one particular person, and it would highlight these particular objects. So yeah.
So I mean, that would, you know, I'm just thinking about current software, that would take another slightly level, you know, some additional, you know, plugins, let's just say, to make sure ownership of the person was tracked during a project, which is I believe in. It is a high level of sort of rigor there.
Well, yeah. But I mean, this is, of course, I have to mention that, of course, this level of ownership, this is enabled by the Speckle platform, right? So each time you create an object or a stream, then it's, if you created it, then you are the owner. If someone else created it, this other person is the owner. So,
and you know, my last question is, have you tried this on, you know, beyond your research into a real project, or is the, you know, sort of the next research with Grimshaw, that is what you're doing there?
Yes, I mean, you know, I'm not part of Grimshaw, so I only have access to the data that they can. I mean, no, I mean, I don't even have access to the data that they actually took the graph, took this tool and deployed it within their practice. But I didn't have access to the data myself, so I don't know exactly what's happening. But of course, I would be super excited to take these sort of tools and you know, deploying them in practice and see how the real world actually would retransform these tools, and you know, they would evolve from real world practice. But I mean, short answer, I have some insights, but I don't. It wasn't really deployed on. I mean, it was deployed on a project, but I don't know what's happening behind the scenes.
Yeah. No. Yeah. Look, it's that's fair. I'm asking the question because, you know, with my experience, you know, any new application tends to be, you know, a challenge for individuals. You know, there's a learning curve. Everyone has a different opinion on how certain software should work. Everyone in the firm has various levels of technical ability, and so you know, it would just be good to know, you know, at some future date, you know, sort of what the next step is for this approach, and you know, how, you know, because my experience is that it has to be dead simple for people to use it, or else they just won't even look at it. They'll just march on with clicking a lot of buttons. So that's all the questions I had. Do you have any questions for me?
No, not particular questions. But thank you.
Well, thank you. It was you know, a very good thesis, and I was you know, sort of glad to see how much work you went into it.
Okay, thank you very much.
Thank you.
Thank you very much, Rob. And we'll just move on to Daniel.
Yeah. So, thank you, Paul. I actually thoroughly enjoyed your presentation, and it was very actually good to see the tools that you developed in action, actually. So it was I was really impressed to see. So thank you again. And then it's enormous work.
Thanks.
That you've done. So I really be really appreciated. I think Jane and Robert already asked very, very valuable questions, and some of them actually overlap of mine. So I'll, if it's allowed, I'll go straight into more detailed questions. And I really like your tool. First of all, you very specifically mentioned at the end of chapter 4 that, well, you can search for that. That's okay. Take your time. You said that you specifically mentioned about 2 challenges. First is about this inevitable late-stage design change, and secondly, this bottleneck in communication and data management. In my opinion, you talked a lot more about this communication and data management in the following chapter, which is chapter 5, and then you should discuss a lot, and you demonstrated more. Though time to time you discussed actually about this, how this will actually reduce or deal with this late stage design change more effectively, and you talked about this hybrid strategy and things like that. Now, just to understand better, when you actually mentioned that, okay, through these workshops that you formulated and implemented in chapter 4, you actually said that you noticed that this late stage design change seems inevitable. And can you, because you actually didn't specifically mention why you actually, what were the evidence, why you actually felt, through which examples you've actually felt that, okay, you know, I did this workshop and you actually thought that based on this late stage design change was inevitable. Who was the, can you tell us a little bit more about that? Where did you actually saw that? And
yeah, sure. For example, I remember in 2016, I was carrying a workshop at KADK, at CITA, where I was actually, you know, sharing the more like the modeling tools that I was developing. You know, they were like graph-based and you know, like based on the modeling experiments that were carried at the beginning of the thesis, and I shared that to the students. And of course, I mean, the brief was very open, and I asked them to use them to actually generate their own design. And also there were contexts, because different groups had to communicate so that their designs were matching with each other. But of course, the tools that I shared were very specific. So as soon as they wanted to focus on particular design that were different than that were different than the design that could be generated with the tools that I showed them, those for me are simple as that, late changes, late stage design changes, and they were, in the end, they were inevitable. I mean, maybe for a couple of groups it was sustainable, but at some points we had to rework the definition together, to break the model, and to operate the changes together. So yeah.
So you're saying that it's, sorry, just to make sure I understood correctly, because normally when I actually heard this, and normally those are late stage design changes in practice and real projects, they normally can happen in various ways. For example, if it's a really one-off innovative project that they really made this geometrically challenging object or component with certain material, which they have to test it, and then they should test it, and they realize that the performance was not quite there, so they have to make a certain modification, which actually have to change other parts and connection joints and things like that. It's nothing. It's in that case, it's of course both the geometrical but the material that didn't really perform the specific component. So you have to maybe either change both. Either you use different material, or you actually change the geometrical design. And I was wondering which specifically you were talking about in your case. For example, you talked about, yeah, sorry.
No, I mean, just to answer what you just asked now, it was more like the geometrical aspect of it.
Yeah. Okay. That just to be clear. But then that's actually clear a few things that I had questioned. Okay. And then you actually mentioned, I'm still with this late stage design change, which I'm quite interested. And of course, this is a very, very difficult question. As you say, it's inevitable, but it's inevitable with the different reasons, and different projects has to deal with this differently. You mentioned in C3 experiment where you're building this specific patterns of strips where you form into doubly curved, and then you mentioned about it. And here I was, you at the end of this, you actually said that the structure analysis was omitted because it was not the focus of the workshop or focus of the investigation, right? If it was a real project, of course, we don't have that option. We have to actually either the software, especially when you say the multi-scale modeling, probably you prefer to some of the software you showed actually did the structure analysis already, and then it was updating. In this case, of course, you have to do that again. You have to be viewed by other professions. Of course, like Robert mentioned, there are a lot more people involved than architects and structural engineers, but maybe in more conventional projects, you have to deal with other like electrical engineers, plumbing, and then where the pipe goes and everything, which you will alter designs here and there. Now, of course, in PhD, the limited time and the scope, you cannot actually develop some kind of arbitrary project which can reflect on all of this, so that you have to narrow down and then tailor your focus here and there. That's completely fine. However, if you actually imagine, because Robert also talked about, if actually this can be seen as something that can be applied or used by, let's just say, more experienced people in practice. Don't know whether it would be other people in Nicholas Grimshaw's office or other people. Then actually the tools, I imagine, have to be actually, like you mentioned in your thesis, those custom tools have to be, again, developed and tailored for their projects. And in my opinion, you mentioned a lot about this seamless design workflows and then integrated things, but then at the end, you actually slowly realize that it's becoming more difficult, and then you actually have to develop a lot of these custom tools. And how do you actually, if you try to make this, if you ever given more time to address this, that, okay, there's of course a serious level of complexity in a real project, and that you have to develop actual tool with custom tools in it, which can actually make this, let's just say, partly direct modeling where things can be very manipulative, and the other part where it's more automated. But then if the custom tools part become larger and larger because every project has their own specification, then first of all, how will you actually deal with this? Because I have a concern that it will then again become, communication problem and data management problem. So you're actually developing, again, going into that direction that, okay, well, actually, as the complexity increases, again, I'll have this ongoing problem, plus, again, late stage design change will be, again, inevitable because it becomes complex. So, because in my opinion, you have developed very, very good theoretical frame, as Jane Burry questions actually tried to address, and I agree with it. In my opinion, this is a very, very, very good foundation and theoretical frame. And as a person who actually developed this, can you actually tell us if you're given more time and if you have more access to, let's just say, practice people, and if you're involved in this specific projects, how would you be able to develop this further, and which part will you focus more?
No, I mean, I think, and actually, the last, for me, this actually refers to the last question, the last research question, and to which I actually answer that realistically speaking, there will always be specific needs for different companies. So, I mean, on this particular point, I I really acknowledge that I don't think that there is a generic technically that there is no generic answer for all cases, of course.
Of course not, no.
But as you mentioned, I think, I mean, that was the attempt of the whole thesis, is as trying to lay out a general theoretical framework where ultimately all these different experiments tackle different skills and could actually be combined throughout a whole project. But of course, if the project changes, one might need to modify some of these experiments or add on top of it. Mm-hmm. So yeah, I mean, I acknowledge this criticism.
No, it's not really criticism. I actually wanted to see that which part you want to actually focus more on, and why you actually see this part more valued for development. I actually wanted to hear your, because I guess you're involved in further involvement with other practice, and then probably you had the time to develop further your ideas and things like this. I wanted to hear more if you want to actually take this further, which personally, as a person who has been working on this for all your PhD years, would like to concentrate on. And that's just, it was rather not criticism, but I really wanted to hear which direction you want to go in the future. So that was just.
Yes. I mean, to answer this, I mean, I would definitely like to go in practice and develop these tools further, and I mean, these tools or others, but yeah, I mean, continuing on a more like custom software developments for AEC. So yeah, moving forward in practice.
For us specifically, yeah. Okay. Actually, along the way, they have answered some of the questions. Now, I actually have very specific questions again. During your tools, your very first tools, where you had a number of different wooden elements, there were you can actually see. You said that the parameter for analysis or the evaluation was actually the wastage or something like that. You actually mentioned. Of course, this parameters actually can be changed to based on different parameters. And then the next one, you actually had, for example, this competition, the design that you actually use the tools for the competition. You can actually do some structure analysis. In this example, you actually show that you could do some structure analysis, and there was some updates and things like that, right? And then you even looked into the manufacturing of the components, and I could see that you have built some small local elements to see whether maybe you had a discussion how it can be manufactured based on the design and things like that. So you wanted to explore a little bit further. Now, my actual question is, when this is actually going back to the multi-scaling, when you actually talk about, because you specifically mentioned about this thesis looking at the material, fabrication, and then structural performance. This was the three things that you actually specifically mentioned. And then I think you can, of course, evaluate the structural performance through the material properties that actually put in the simulation, so that they could be evaluated. But when you actually come to the fabrication, in terms of communication, do you actually, because you cannot really assume that it can be fabricated from the beginning. You actually design first, and then go to the fabricator, and they said, can this be successfully fabricated or like manufactured in the way? And if they test something, and then if they want to communicate that result, and in your tool, you have to actually them to specifically put this into that tool. Am I right?
Yeah. Yes. Because
that's the bit that I'm a little bit confused, because if it's proper communication, for example, if it's everybody is shared this platform, then clearly the designer designs something parametrically, and then they go to the manufacturer and then manufacture it, and they say, okay, we can actually manufacture this to the given tolerance.
Mm-hmm.
So how did they actually communicate such a thing back to the designer?
Yeah, I mean, in the particular experiment that you mentioned, so
Yeah.
as I mentioned, it was a common work with Tom's villains, and here we were working at different scales. So I was more looking at the more like overall like form generation of the structure, and Tom was looking at how the material could behave, and looking more specifically at tolerances when tolerances as each piece was supposed to be glue laminated and bent and without any steaming. So then once the tolerances were found, we're able to actually get some feedback from the model to take the mean radius of each elements that was generated, and according to this, like learn whether or not the model was sustainable, and if it was not, then some changes were operated at a higher level.
Okay, so just going back to the question again. So in terms of communication and data sharing, sorry if you actually answered my question, but maybe my understanding is a little bit short, so I apologize if I'm asking the same question again. You actually designed something through your tool, and then seems like your tool has evaluated the simulation already have this evaluation function based on the geometric tolerances and then the material properties, and then your simulation says, okay, this is fine. And then you actually send this to the manufacturer or subcontractors, whoever.
Yes, but I mean, in this case, for the few prototypes that we fabricated, the manufacturers were Tom and myself, and we went to the lab and took the final geometry of the piece, laid it out on the formwork, and yeah, so it was tested it like this. Of course, I mean the project wasn't fully fabricated, so we could only do that for 3 or 4 pieces.
Yes. I mean, yeah. The question is, if you was sent to some kind of manufacturer, and then they have to make some kind of changes to the design, and the question is, the backflow. It's not like one direction. They have to also inform the others. Yes. And I was just asking you about that communication. How can that be effective on using your tool?
Yeah. No, I mean, then the tool would have to. I mean, we would have to make some changes on a higher level.
Extra plugins, huh?
Yeah.
Extra definitions to accommodate that. That's like what Robert also mentioned briefly about those. Which is fine. I just wanted you to see whether you actually had those, because I was quite impressed by your tool, and I was trying to understand what were the actually fully embedded functions that your tools had, and then what could be the limit, what could be the actual possibilities. Because based on my experience, I don't believe in this like one direction, and then you actually nail everything down and then just send it to manufacturer and they'll do it. Most of the design changes actually happen because manufacturers cannot give what you ask for. You have to actually verify this in early design stage, and this is why it's good to have a design team that you discuss from the beginning.
But actually this wasn't maybe not as well illustrated, not really well illustrated for this particular experiments with Tom, but actually there was another modeling experiment where actually made a constraint-based simulation to actually relax the graph at a high level, so that each angle between each segments was conform towards specific parameters.
Yeah. Thank you. Actually, that's all the question I had, Mette. Okay. Yeah. So I'll stop there. Thank you again. It was very nice.
Thank you very much, Daniel.
Thank you.
Super. Well, thank you very much, all of you. Well done, Mary Catherine. We have a little break now. The committee will now go into sort of a parallel space in Zoom and deliberate. And they, I mean, the only requirement is that this doesn't take more than 50 minutes. So you have a lot of time. And the rest of us, I think it would be really wonderful for Paul that some of us hang around and hear what's going on. I'm sure it's all a cliffhanger anyway, but it would also be very nice for Paul, of course.
Thank you,
So,
everyone, for the comments and
yeah.
all the questions.
Thank you, Paul. Thank you for the
Thank you
answers.
very much for the intensity. So.
Thank you, Paul.
Okay, bye.
Okay, so we just had a meeting and we conclude by giving the following recommendation. The committee unanimously finds that Paul Poyner, through his written thesis and the public defense, has proved to have successfully completed an independent scientific project through methods applied within the field of architecture and related disciplines. The thesis contributes to promote the research at a level equivalent to the international PhD standard within the discipline. The committee therefore recommends that the Royal Danish Academy of Fine Arts, Schools of Architecture, Design and Conservation awards Paul Poyner the PhD degree.